Hello, everyone, and welcome to another episode of the Day 1 to Deep Tech podcast series, where we explore the people, technologies, and real world stories behind today's most exciting engineering careers. Today's conversation is about full stack engineering, one of the most dynamic and in demand fields in the technology industry. Every time you order food online, book a cab, shop on an e commerce website, stream a movie, use internet banking, or collaborate with your team through a web application, you're interacting with software built by engineers who understand how every layer of an application works. But have you ever wondered what it actually takes to build a modern web application from scratch? How does a simple click on a button travel through the internet, reach a server, retrieve information from a database, and display the result on your screen in just a fraction of a second? To help us answer these questions, we're joined by the founder of a full stack engineering startup that has built web platforms, SaaS products, and digital solutions for businesses across multiple industries. Thank you so much for joining us today.
Thank you for inviting me. It's a pleasure to be here. One of the things I love most about full stack engineering is that almost everyone uses software every day, but very few people stop to think about the engineering behind it. When someone opens a website, they usually notice the design, the speed, or how easy it is to use. As engineers, we see something completely different. We see thousands of decisions working together: user interfaces, databases, APIs, authentication, cloud infrastructure, security, deployment pipelines, and countless lines of code collaborating to create a seamless experience. That's what makes full stack engineering so fascinating.
Let's go back to where your journey began. Did you always know you wanted to become a software engineer?
Not at all. Like many people, I started with curiosity rather than a career plan. When I was in college, I enjoyed solving logical problems, but I had no idea what full stack engineering even meant. I thought software development was mostly about writing code. Then one day, I tried building a very simple personal website. It only had a few pages, my profile, some photos, and a contact form. Looking back, it wasn't particularly impressive. But seeing something I had created appear in a web browser was an unforgettable experience. It felt like I had built something that anyone in the world could access. That moment completely changed how I viewed technology.
It's amazing how one small project can influence an entire career. What happened next?
Curiosity took over. After learning how to build static web pages, I wanted to know how websites became interactive. How do users create accounts? Where is their information stored? How does a shopping cart remember what I've added? How do websites process payments? How do thousands or even millions of people use the same application at the same time? Every question led me to another area of software engineering. Without realizing it, I was exploring front end development, back end development, databases, APIs, authentication, and cloud computing. At first, they seemed like completely different technologies. Later, I realized they were all pieces of the same puzzle.
Many people hear the term full stack engineer but aren't quite sure what it means. What does it actually mean to be a full stack engineer?
A simple way to think about it is this. Imagine you're building a restaurant. The dining area is what customers see and interact with. That's similar to the front end of a web application. The kitchen is where food is prepared behind the scenes. That's like the back end. The pantry stores ingredients. That's your database. The waiters carry orders between customers in the kitchen. That's similar to APIs that move information between different parts of the application. A full stack engineer understands how all of these areas work together. You don't necessarily become the world's greatest expert in every technology, but you understand the complete system well enough to build and maintain an entire application.
That's a fantastic analogy. What was your first professional role after college?
I joined a small software startup as a junior developer. I imagined I'd spend every day writing exciting new features. Instead, I spent a lot of time fixing bugs. At first, I thought debugging was a sign that something had gone wrong. Over time, I realized debugging is simply a part of engineering. Every bug teaches you something about how software behaves in the real world. Some of the most valuable lessons in my career came from fixing problems rather than writing new code.
Was there a moment when you realized full stack engineering was going to become your long term career?
Yes, our team was developing an online platform for a client. One day, I was working on the user interface. The next day, I was writing backend logic. Later, I connected the application to a database. Yet, finally, we deployed the application to the cloud. Watching every piece come together into a working product was incredibly satisfying. I realized I wasn't just writing code. I was building complete digital experiences that people relied on every day. That's when I truly understood the value of full stack engineering.
Many beginners assume software development is mostly about programming languages. Was that your biggest misconception too?
Absolutely. I thought learning one programming language would make me a software engineer. It doesn't work that way. Programming languages are important, but they're just tools. Building modern applications requires understanding users, designing interfaces, organizing data, creating secure systems, testing software, collaborating with teams, deploying applications, and continuously improving products. Coding is only one part of the journey. Engineering is about solving problems.
That seems to be a common theme across many engineering disciplines. Technology is important, but problem solving is even more important.
Exactly. One lesson I've learned is that users don't care which framework you use. They care whether the application works. They care whether it's fast, whether it's secure, whether it's reliable, whether it solves their problem. Technology helps us achieve those goals, but it should never become the goal itself.
Looking back, what advice would you give your younger self when you were just beginning on?
I tell myself to build more projects and worry less about being perfect. Don't spend months watching tutorials without creating anything. Build a personal portfolio, create a simple blog, develop a to-do application, build an online bookstore, experiment with APIs, deploy your applications. Every project teaches lessons that no textbook can fully explain. The sooner you start building, the sooner you'll start growing.
Before we finish this first part, I'd like to ask one final question. Why do you think full stack engineering has become such an exciting career?
Because software is everywhere: healthcare, education, banking, retail, transportation, entertainment, manufacturing, agriculture, government. Almost every industry today depends on software. And full stack engineers have the opportunity to build products that improve how people work, communicate, learn, shop, travel, and solve everyday problems. Every application begins as an idea. Full stack engineers help transform those ideas into products that millions of people can use. That's an incredibly rewarding responsibility.
That's a wonderful way to begin today's conversation. We've learned that full stack engineering isn't simply about learning programming languages. It's about understanding how complete software systems are designed, built, deployed, and continuously improved. In the next segment, we'll explore what the industry is really like. We'll discuss what textbooks often leave out, why full stack engineering is much more than coding, and naturally introduce concepts like HTML, CSS, JavaScript, front-end frameworks, back-end development, databases, APIs, authentication, Git, cloud deployment, and software development workflows through real-world experiences. Stay with us.